So we start to kind of look at our matter. First thing we can start to do is to make some observations, looking at our substances and kind of thinking about how we can describe and start to compare our different types of samples. And so the very kind of fundamental way we can start to do that is based upon whether we're looking at a physical or a chemical property. A physical property is just describing its outward appearance. So for example, if I had a beaker full of water, I could say, well, that's in its liquid state. That's just a physical description of the current state of that water. That would be a physical property. A change in a substance that does not involve a change in the identity of that substance is called a physical change. So if I were to take that water and freeze it, I've changed it from its liquid phase to its solid phase, but it's still water. That would be an example of a physical change, a change that does not change the actual substance. For example, if I took a sticky note, little yellow sticky note, I could describe it in a lot of different ways. I could say it's yellow. That's a physical property. I could say it's a solid physical property. It has a high tensile strength. I can pull on it without it breaking. Again, all of these are physical properties. If I were to rip it in half, oh, well, that's a physical change. I've changed its outward appearance a little bit, but it's still a sticky note. It's still paper. That's a physical change. Conversely, if we were going to go ahead and change that substance, we would call that a chemical change. A change in which a substance is made into a different substance is called a chemical change. A new substance is created. If I took my little sticky note and I were to burn it, now I've changed it into ash. It is a chemical change of that paper. It's going to actually have new chemical and physical properties. A product that is formed as a result of chemical change have different physical and chemical properties than the original material. My original material had a high tensile strength. My ash is going to be a powder. It will crumble. It no longer retains those physical properties because we've made something new. Decomposition of that water, if I took that beaker of water, I stuck two wires in there, I could actually split it apart and break it off into hydrogen and oxygen. They're going to be gases now. They're going to be highly flammable. The water was not flammable before. Sometimes we got cleaning products that will release some ammonia gas. We then would say we've got a chemical change. We've released something new that wasn't present before. If we're just describing how something could change, we call that a chemical property. Acids, for example, are corrosive. They eat away at things. That would be a chemical property for our different acidic substances. What's nice is there's some things we can look for when determining whether this was a physical or chemical change. And if we really start to kind of drill down into what kind of constitutes or will tell us whether or not we've had a chemical change, because it's kind of hard to see sometimes bonds breaking and forming. So there's five kind of ways or five indicators that we've had a chemical change take place. If all of a sudden you've got a production of a gas, some bubbles are coming off. And now we're not saying we're boiling. We didn't put a bunch of heat and energy in to the point where for example, liquid water became steam. It's not what we're doing. Took two liquids, we poured them together, gave off some bubbles. That would be an indicator we've made something new in the form of a gas. A chemical change has occurred. Usually with that gas coming off, oftentimes there'll be a stank. There'll be some odor that is released, another sign that there is a chemical change taking place. Sometimes there's an energy change. There's a change in the energy. If the energy is being absorbed, if it's being taken in, we call that endothermic. Heat energy is being absorbed. An example of this would be those instant ice packs where you kind of break the seal in the middle, you shake it up, and all of a sudden it becomes cold to the touch. Well, that means it's absorbing your heat energy. It feels cooler or cold to you. That's an endothermic reaction. Exothermic, that would be the release of energy. If we go back to burning our little sticky note, that would be exothermic, releasing heat energy. And again, we're not doing it to the reaction. We're saying that all of a sudden we have spontaneously made a change in energy. That's one of our signs that we're making or breaking bonds. If we had a production of a precipitate, now little vocab word here real quick, a precipitate specifically in chemistry is the formation of a solid. We're not freezing it. Oftentimes our precipitate looks a little different in that we've put two liquids together that were originally transparent. And all of a sudden it's become cloudy. We've got little tiny precipitate or particles that we can no longer see through the substance. That is a precipitate, the formation of a precipitate. And then the last one, which can be kind of tricky to think about, is a change in color. Not a new, not just a slight dilution of color, but an actual new color that wasn't present before. And so if we start to see any of these 5 indicators, oftentimes we can go, I bet we have had a chemical change. Let's stop and take a look at some of these examples, and then we'll kind of talk about our other types of observations. So first kind of example I wanted to look at when we start to think about chemical and physical properties is one that I think is oftentimes misconstrued. So all we've got here, we've got a beaker of distilled deionized water. So very, very pure water, does not have any charged particles in it whatsoever. We could describe it. It is liquid, that would be a physical property. It is colorless, tasteless. Again, all of these are physical properties. To which I'm going to add kind of what we call this is potassium chlorate. Potassium permanganate. And so it's kind of this kind of darker crystalline substance. Wanted to get you a little bit of contrast. It's kind of hard to see, but there's actually a purple color to our crystals here. It's a little hard to see on the camera, but worth noting because, again, I think this one is the most often mistaken type of change. If I put this into our water here, give it a little bit of a stir, a little hard to see on that black background. Let me go ahead and put it on our white backdrop here. You'll actually notice that our solution has quote unquote changed. We now have a very nice, let me rinse this off real quick, a nice purple solution. So now the question becomes, was there a color change? If the crystals were purple before, and we put them into water, we've essentially made a solution here, we dissolve them into solution, and now we have a purple solution, have we had a color change? Have we made something new? And the answer is no. This is the most frequently erroneous observation. This is still a physical change. All we did was we took our crystals and we dissolved them into solution. We could get those crystals back. If we put a little heat energy in and we boil off the water, we can get the potassium permanganate back out of solution via a physical property. We've not broken or rearranged any bonds. We now have just a homogeneous solution. If we were to then add something and then we had one of our other signs, we'd start to think, well, maybe this was a chemical reaction, but this is not a new color. This is still a purple color. Here we got a little piece of tissue paper. We could describe it. It is solid at room temperature. That's a physical property. I could tear it. That is a physical change. I could crumple it. Also a physical change. It's still the same paper. If I were to apply a little energy to this paper, we could actually then have a change in energy. We see some light being released. It's a little hard to see, but there's some smoke coming off of our combustion here. We're having a change of our chemical and physical properties. We can see the color changing now from white to black. This is a color change, and eventually to kind of our ashen color. We've got heat energy being released. This is an exothermic process, and we've got new properties at the completion of our combustion. Another example, and this one's kind of a new one for us. This is not only a color change for us, hopefully, but also a formation of a precipitate. So we've got two different solutions here. We've got potassium dichromate, and we've got our silver nitrate. Silver nitrate is kind of this colorless substance. So let me get my backdrop for you again, so it's a little easier to see. We've got this colorless liquid. We've got kind of this amber yellow liquid for our other reactant here. And I'm going to go ahead and grab a spot plate so we can kind of see what's going on here a little bit more clearly. I'm going to put both into the same well for us. And when we do, we get a very distinct change in color. We went from amber and colorless to this very much bright red, kind of blood red color. If we look closely, it is also no longer transparent. If I let this sit long enough, it would actually settle out and we'd have little tiny solid flakes filter or settle down to the bottom of our spot plate. Not only did we have a color change, we've also created a precipitate. Both of these should key us in that, hey, we have made something new. There has been a chemical reaction that has taken place. Our other observations that we can start to have are quantitative and qualitative. And you've been doing these your whole life. We're just going to give them some terms so that we can start to describe them accurately. A quantitative observation, oh, it's so nice. It's right in the word, quantity. We're looking at numbers. A quantitative observation includes the use of a measured numerical value. And so we've taken a tool and we've got some numbers to actually assign to our measurement. If I said that the height of this room is 2.4 meters, we would say that it is a quantitative observation. There are numbers attached. We said that the oven is cooking at 54.5 degrees Celsius. Again, we have numbers. We use a thermometer. A tool has been used to actually gather that quantitative data. Qualitative observation is just a general observation, usually based upon our senses. If we said that the room is tall, I didn't measure anything. I just kind of said, well, it's a tall room. If the oven is hot, again, no measurement was done. We're just describing it. A lot of times we can kind of classify observations. I imagine you're quite good at these. Not a bad idea to kind of think about when we're making these observations, what type of observation that we're looking at. We're going to be doing a lot of these types of kind of classification of observations over the course of the year. It's good for us to stop and think about how we actually go about describing our substances.